Have you ever wondered if there's more to the world than meets the eye? I mean, literally. What if we could see the hidden colors all around us? Today, we're diving into a fascinating thought experiment. What if humans could see in infrared and ultraviolet? First, let's talk about what that even means. Our eyes are amazing, but they only see a tiny slice of the light spectrum, which we call visible light. Think of it like a piano. We can only hear the middle keys, but their high and low notes we're completely missing. Those are the ultraviolet and infrared ranges. So let's unlock those abilities. Imagine you wake up one morning and suddenly you can see in infrared. The world would be a symphony of heat. You'd look at your coffee mug, and it wouldn't just be black. It would glow with a warm, radiating light. A cold glass of water would look dark and dim. Your pet cat sleeping in a sunbeam would be a brilliant, bright shape against the cooler floor. You could see the ghostly heat trail of a car that just drove by, or the warm footprints of someone who walked across the carpet moments ago. In a crowded room, people would look like living flames, their body heat painting a dynamic, ever-shifting picture of life. It would be incredibly useful for finding someone lost in the dark or spotting an animal hiding in the bushes at night. Even the walls of your house would tell a story, revealing where the insulation is weak or where a hidden water pipe is leaking, simply by the temperature differences. But it would also be overwhelming. Our brains are wired to process light bouncing off objects, not the heat they emit. Everything would have this constant, shimmering glow. It might be hard to distinguish objects based on their color alone. Is that shirt red, or is it just warm? It's a whole new layer of information our brains would have to learn to interpret. Now, let's add ultraviolet vision to the mix. This is the world many insects and birds experience every day. The world wouldn't just be brighter, it would be covered in secret patterns. Many flowers have ultraviolet markings called nectar guides, which are totally invisible to us. To a bee, a plain yellow sunflower is a mesmerizing bullseye, with patterns pointing directly to the nectar. With UV vision, a simple walk through a garden would become an alien, psychedelic experience. Flowers would have intricate, glowing designs we've never dreamed of. Animals would look different too. The fur of some mammals and the feathers of birds have unique UV patterns that they use to recognize each other and choose mates. A bird that looks plain brown to us might be dazzlingly iridescent in the UV spectrum. You'd see spider webs glowing in the sunlight, making them easier to spot or follow the UV trails left by some animals to track them. But there's a downside here as well. The sun is a massive source of UV light. Without the natural filter our current lenses provide, looking at the sky could be blindingly intense. We'd see the hazy glow of our atmosphere in a completely new way. Surfaces that reflect UV light, like certain types of paint or even snow, would be painfully bright. It would be sensory overload on a massive scale. So, if seeing in infrared and ultraviolet is so cool, why can't we do it? The answer lies in our evolution and biology. Our vision system is a masterpiece of trade-offs, optimized for our specific survival needs. Let's start with the structure of our eye. The lens in our eye is a natural filter. It blocks most of the UV radiation from reaching our retina. This is a crucial protective feature. UV light is high energy and can cause significant damage to the delicate cells of the retina, leading to conditions like cataracts and macular degeneration. Our eyes evolved to prioritize long-term health over seeing a few extra colors. If we had UV-sensitive cells, our vision would likely degrade much faster over our lifetime. The very thing that would let us see these hidden patterns would also be destroying our ability to see at all. Then there's the infrared side of things. To detect infrared light, which is essentially heat radiation, our eyes would need a completely different kind of sensor. The problem is, our own bodies are warm. We're constantly emitting infrared radiation. If our eyes were sensitive to it, we'd be blinded by our own internal heat. It would be like trying to take a picture with the lens cap on, but the lens cap is glowing. The noise from our own body heat the blood flowing through the vessels in our eyes. The warmth of the eyeball itself would overwhelm any external signal. Animals that can see infrared, like pit vipers, don't use their eyes. They have special pit organs on their faces, separate from their visual system, that detect heat. This keeps the heat sensing function away from the noise of their own eyes. For us to evolve a similar ability, we'd need a radical redesign of our sensory organs. Furthermore, our brains are fine-tuned for the visible spectrum. We've evolved to see the world in terms of reflected light, which gives us incredible detail, depth perception, and color differentiation. This is perfect for the world our ancestors inhabited, finding ripe fruit, spotting predators in daylight, and navigating complex environments. Adding in thermal and UV data would require immense processing power. Our brains would need to be rewired to make sense of this flood of new information and not get confused. Think about it. Your brain would be trying to process shape, color, texture, reflected light, emitted heat, and UV patterns all at once for every single object in your field of view. It's not that it's impossible, but it wasn't the most efficient path for our survival. Evolution is all about being good enough. Our vision is more than good enough. It's spectacular for the tasks we needed to perform to thrive as a species. In a way, we're lucky. We have a clear, high-resolution view of the world that is protected from the damaging effects of UV light and is uncluttered by the thermal noise of our own body. Our vision gives us the exact information we need to navigate our world safely and effectively. While we can't see these spectrums naturally, technology has given us superpowers. We've built infrared cameras that let us see heat in UV cameras that reveal those hidden floral patterns. We've essentially outsourced these abilities, allowing us to peek into these invisible worlds without having to deal with the biological drawbacks. We can explore the universe in every wavelength, from radio waves to gamma rays, all thanks to our ingenuity. So, while it's fun to imagine a world of glowing heatscapes and psychedelic flowers, our human vision is perfectly tailored for us. It gives us a beautiful, detailed, and safe window onto reality. The invisible worlds will remain a mystery to our naked eyes, but that just makes them all the more fascinating to explore with the tools we've created. What do you think? Would you trade your current vision for the ability to see in infrared or ultraviolet, even with the downsides? Let me know in the comments below. Thanks for watching. And if you enjoyed this journey beyond the visible, make sure to like and subscribe for more explorations into the wonders of science. See you next time, and stay curious.